So let's go ahead and talk about the problem of the day. Be sure to answer the questions I ask out loud. Think about how your work is the same or different from what we talk about together. All right, first question. We have the story problem here. How could we represent it? Say it out loud. Yeah, there's lots of different things you might have said. One might have been a tape diagram, right? Where we have something like this, and we say, great, we've got 5/10 as one part, and that's going to be our blue, right? And then we have 14/100. That's the other part. That's our green squares. And then our unknown is the total, right? And that's T, and that's the blue, right, and green together. Yeah, that would work. Some of you also probably just did a number sentence, right? We know from the problem that we've got 5/10 of the quilt is blue squares. We know that 14/100 is green squares. And we are trying to find the total amount that is blue, right, and green squares. So I'll put total blue and green. Yeah, either way works. There's other ways that could work too, as long as it accurately represents what's happening in the problem and shows what it is we're trying to figure out. Okay, so what do we need to do in order to start solving, and why? Go ahead and say it out loud. Yep, we have to rename 5/10 to give it a denominator of hundreds because we know that our fractions have to be the same denominators in order to add them. How are we going to do this? Say it out loud. Yeah, we can take 5/10, we can multiply by a fraction with the numerator and denominator of 10, because we know that when we multiply the numerator and denominator of a fraction by the same number, we get an equivalent fraction. And in this case, 10 times 10 is 100, so that gives us a fraction with a denominator of 100, and then 5 times 10, 50. 5/10 is the same as 50/100. Okay, great. And then how will I solve? Say it out loud. Right, I can take 50/100, I can add 14/100, and I get 64/100, 64 out of 100. And how would I write that as a decimal? And why? Say it out loud. Right, I can write it as, that's equal to 0.64, right? Our denominator tells us that we're going to have hundredths for the place value, and the numerator tells us how many we have, which in this case is 64. What if I wanted to double check and make sure that this answer made sense? What could I do? Say it out loud. Yeah, I could actually take my 64/100 and I could add 36/100, and that should give me 100/100, right, or one whole, because those are all the parts of the quilt, and I know that the quilt is made up of 100 squares. So let's do that real quick. I'm just going to put a check right here. We can take 64/100, right, plus the 36/100 that are red and yellow. That does in fact equal 100 out of 100, and that makes sense, right? That's one whole. We have a quilt that is 100 squares. So this accounts for 100 out of the possible 100 squares. Okay, so that means that we can be pretty sure that 64 hundredths are blue and green. Great. Now, what did I have to do before I could actually solve this problem? And will I always need to do that? Say it out loud. Yeah, I had to rename the tenths as hundredths so that I could then add fractions that had the same denominator. But we're not always going to have to do this. We only have to do that when the denominator of the fractions is not the same like it was in this case.